root. So here we are in 3b on the 7-7 green worksheet, and 3b says the zeros are at plus or minus 2I. There's a double root at negative 2 and a single root at 5. So let's go ahead with 2b, and let's go ahead and write out the possible equation. Let's forget about this for a minute, okay? In red, we're going to leave that out, but we're going to go ahead and consider this. X equals negative 2, a double root. So what would that parentheses look like if it's x minus 2 and it's a double root? X plus 2 squared. X plus 2 squared is what you're going to have there. And then on the end here, we have x equals 5 as a single root. So what does that look like? X minus 5, and it's not squared, it's not cubed, it's a single root. Good? Now let's go back and consider what we have there in red. It says plus or minus 2I. So I think all we need to do here is make one set of parentheses for the x minus 2I and another for the x plus 2I. So this polynomial actually has 5 solutions, or 5 roots. It's just that 2 of them are what kind? Imaginary. So they don't really strike the axis there, but you can get values that would create 0. They're non-real numbers that you could plug into the equation to produce 0. All right? But they're not on the x-axis. They're not on the real number system. That's odd. That's weird. So that's basically the equation, but we don't know what A is. For all of these problems, I don't care which one you're doing, we always need to know what the dilation is, or what the reflection is, or both. All right? So that's the last piece of the puzzle for all of these, is to figure out what A is. But to figure out what A is, you need a point to plug in. They give that to us right here. They tell us that when y is 80, it's the y-intercept. So what's x at the y-intercept? 0. So all I did was I made 4 sets of parentheses, and I'm going to plug in 0 and see what I get. All right? What do you get when you do 0 minus 2i? Minus 2i. 0 plus 2i. 2i. 0 plus 2 squared. 4, and 0 minus 5. Negative 5. So I'm real close to finding the missing A. It's just a matter of multiplying. The tricky part is right here. Do you know what negative 2i times 2i makes? Negative 4i squared. But we don't want to leave that as I squared. I said never leave an I squared. It's just 4. Because that's negative 4 times negative 1. I squared is negative 1. So let's go down the line here. 80 equals A times, we said this makes what? 4 times, what's 4 times negative 5? Negative 20. Oh, this is almost done. What's negative 20 times 4? If negative 80A equals 80, A must be negative 1. So the final solution is what I have up there with a negative in front of it. All right? Which was the answer that was on the solution key. That's y equals negative x minus 2i. Great time to do this. X plus 2i. Now that I'm done with the problem, thanks a lot. Times x plus 2 squared times what? Go ahead. Times what? X minus 5. So this would be a polynomial that has solutions at negative 2, 5, 2i, and negative 2i. Those are all the values, complex or real, that would produce 0. And sorry, it's a little messed.